Sometimes for logs you have to worry about whether solutions check out, because remember, a log has a domain from 0 to infinity. So you got to make sure that your log values actually make sense for the equation. So first thing I'm going to do is I'm going to combine my logs. Since I'm adding two logs together, I can combine as 5x times x minus 1. And all of that is still inside the log. And I get equals 2. So now, you can go ahead and multiply that out. I get log of 5x squared minus 5x equals 2. And since this is log base 10, I'm going to raise everything to a power of 10. So the log, that's a base 10, so that cancels. I'm left with 5x squared minus 5x equals 100. Move the 100 over, and I get 5x squared minus 5x minus 100 equals 0. Factor out of 5, or divide everything by 5, and I'm left with x squared minus x minus 20 equals 0. So now when I come over here and actually solve it, when I factor that, I get x minus 5, x plus 4 equals 0. Well, set each factor equal to 0. X minus 5 equals 0, and x plus 4 equals 0. Well, when I solve for the top one, I get x equals 5. Down below, I get x equals negative 4. So you would think I would have two solutions, but that's not really the case, because what's going to actually happen is, if I go back and check 5, okay, I can take net 5 times x, or 5 times 5 is 25. I can take log of a positive number, and I plug 5 in for the x minus 1 here. I get 5 minus 1, which is 4. So that's okay. But the problem is the negative 4, if I plug it in up here, I'm taking log of a negative number, and that can't happen. So that's why the negative 4 doesn't work. With exponents, you don't really have to worry about your solutions having to check to see if your solutions make sense. But with logs, especially because of this domain aspect, you have to be very, very, very careful to make sure your logs work. How about a S?